Okay, in this video I'm going to talk about the segments connecting the midpoints of arcs of the circumcircle of a cyclic quadrilateral and the fact that they're perpendicular to each other. So basically we have a cyclic quadrilateral, which means that it's inscribed in a circle. So basically we have a circle where we have a quadrilateral inscribed into it, and we have the arcs like these vertices of quadrilateral divide the circle into 4 arcs, and we take the midpoints of these arcs. So basically such that this arc is equal to this. This is midpoint of this arc. This is midpoint of this arc. This is the midpoint of this arc. And so we take the segments connecting the opposite midpoints. Yeah, so here like it would be better to write connecting not just the midpoints but the midpoints of the opposite arcs. Yeah, like of the opposite arcs. Of the opposite arcs of the circumcircle. So these two segments basically. And the theorem is that they are perpendicular to each other. So if we denote the points A, B, C, D, and here it is M, N, K, L, then the theorem is that MK is perpendicular to NL. Okay, so let's prove this. So basically we use the theorem that the angle between two chords in a circle is equal to half of the sum of these two arcs, right? So like if this arc is let's say this arc is alpha and this arc is beta, then this angle, if we denote it by gamma, so this angle gamma would be 1/2 of alpha plus beta. So this is a theorem, like I proved it in a separate video. So that's what we are going to use. So here let's remove the right angle. We don't know yet that it's a right angle. And so basically what we need is these two arcs. The arc. So the angle that we need, so if we denote this point by P, so the angle NPK that we need to calculate is equal to 1/2 of the angle 1/2 of the arc MAL plus the arc NCK. So that's using this theorem. And now basically let's denote the arcs. So so let's denote this arc alpha alpha. So these are equal. So the arc AB would be 2 alpha. So this beta beta, this gamma gamma, and this delta delta. So now let's now I will remove this theorem so that not to confuse the angles alpha, beta, and gamma that we used in the main statement, not to confuse them with the angles in this theorem. So this is equal to 1/2 of MAL. This would be alpha plus delta, right? So alpha plus delta, and NCK, this would be beta plus gamma. So plus 1/2 of beta plus gamma. So in total this would be 1/2. This is 1/2 of alpha plus beta plus gamma plus delta. Right. On the other hand, we have that the full circle, so 360 degrees, is equal to like 2 alpha plus 2 beta plus 2 gamma plus 2 delta, right? So 2 alpha plus 2 beta plus 2 gamma plus 2 delta. So from this we conclude that alpha plus beta plus gamma plus delta is equal to 180 degrees. So if we now substitute it here, so this is 1/2 of 180 degrees, and this is simply 90 degrees. So the angle NPK, this angle, we calculated that this is equal to 90 degrees, so this is indeed right angle. And this, well, we can write it explicitly. So from this it follows that MK is perpendicular to NL. And this concludes the proof.